Hi everyone, my name is Bhavishya. In the previous one, we talked about the concept of VLANs. Let's move forward with the concept of ARP. So, in order to send data fully, we need two things. The very first is IP address, and the second one is MAC address, right? Now, if we have a situation where we have the IP address of a device but not its respective MAC address, then what do? So to bridge this concept, to bridge this situation, we have concept called ARP, which is Address Resolution Protocol. So let's understand. So let's take a scenario. I'll take two examples to understand what exactly ARP is, how does it really work. But for now, to give you a little analogy of how it works. So basically, we don't know the address of the device, so we will create a frame where we will broadcast it to every respective network connected to us. So the one which is intended with matches the IP address perfectly, it will receive the frame and now it will generate a response to it. So, and in the response it will unicast the MAC address. So in ARP we have two things. We do the ARP request, then we receive the ARP response. So now let's take an example. Let's take an example where we are communicating within the network. So let's suppose PC1 is connected to PC2. It has the IP address of it but not its corresponding MAC address. So now, as it is within the network, so our request will happen directly. Okay, so PC1's create a frame where we have a destination IP as the intended IP of the device. We have source IP as our own IP address. We have the type as 1. Here 1 means ARP request. Okay, we have source MAC as our own MAC address. We have destination MAC as all Fs or broadcast, because we want to send it to everyone connected to us to identify which matches the IP address intended. And in the type field of this particular frame, we will input it as 0806, which is ARP. In the case of IP, we are using 0800, but in ARP we will use 0806. Now the frame goes to every corresponding connected device, and the one which is intended to with the same IP address receives it. Now when it receives it, it will create a response packet or response packet in its frame. Now in the response one, it will change the type field to 2, which is our ARP response. It will change the MAC address to its own and it will unicast it. Now we have the MAC address of this particular device that we were looking for. So this was the example 1. In the example 2, so let's suppose we want to communicate outside of the network. Now PC1 wants to send data outside of its network, so he can't directly just jump upon doing an ARP request. No, he can't do it. First, he needs to identify the MAC address of the default gateway. So now our intention is to identify the MAC address of the default gateway first. So he will create the frame. The source IP is our own IP of the, let's suppose, PC1. The destination IP is the IP of the intended IP address or the receiver's address. Now in the type field we have 1. In the source MAC we have our own MAC address. In the destination MAC we will fill it as all Fs broadcast. In the type field we will fill 0806 ARP. Now as it reaches the default gateway, he'll accept it out of every other device. He'll accept it. He'll generate a ARP request. In the type field he will input 2 as ARP response. In the MAC address he will input its own MAC address and he will unicast it directly to the PC1. After this, PC1 will create a new frame where he will input the intended MAC address of the default gateway, and now this packet reaches to default gateway, and further he will do the respective things that he do in order to communicate to the network. So this was the concept. Let me quickly conclude this by devising a bit about ARP. So ARP has two things. First is request and second is response. In request we do broadcasting, and in response we do unicasting. So this was the concept of ARP. I hope you enjoyed and learned something out of it. See you in the next one.